Start recording. Okay, cool. I'll get started. So, close these. So I guess I'll start off by doing the going over the homework. I think I did most of it in the lecture actually last time. But long story short, everyone should have by now 3 characters, spells, weapons, pets, and you can easily add as many as you want now because you have a really easy way to like add stuff in your character and like add weapon or just push to the array or something like this. And then a lot of initializers in the character. I took one step further because one thing I did was, we had like the level up function, and we were kind of comparing like this.class name is equal to shaman, these strings, and then over in the shaman I was kind of going like I was passing in the string shaman here as well. And then if you level up and if it is the shaman, you get those kind of bonus stats, if you guys remember doing that from the homework. So I found that very brittle. So what I did was I made some constants in this config. So I have a config object here in the config folder, and I'm going to put some game config stuff there. So I've got like my config object and then class names, which is another object, and it's got my class names here. And then now I can refer to those from multiple files to make sure that they're always equal. So I've got like comparing the class name to the constant here, which is the value of it is, the word shaman. But when I create it in the shaman, I can pass it in at the same time. So instead of comparing really brittle strings everywhere, I'm comparing the same string from a constant file because I always want it to be the same. So that's just a little improvement I did as well. Other than that, I've just still got my basic stuff from last thing, the spell names, fireball, light heal, the spell. And then the weapon as well, which is weapon damage. So you can see if I go to my game, and I can be like, okay, console.log shaman.get damage. Oops. It's undefined because I don't have a default damage for this guy. My shaman doesn't really deal damage unless I say cast, or unless I do like shaman.equip weapon Thunder Fury. Because of the logic of my shaman, he needs a weapon. Now it's 13. And then you see if I misspell it when I equip the weapon, I get undefined again, so it's not a real weapon. And then kind of the same, I can console.log my mage.get damage, but I can pass in like, I think I gave him fireball. Let's go double check in my mage. Yes, I do. He has fireball. I can see here. So in my game, when I call, I can just pass in the string fireball of the spell that I'm going to do. And oops, you can get rid of that one. You can see that it's 12 because he actually has fireball. So I don't know how you guys implemented the get spell stuff, the damage stuff, but I basically just said, instead of setting an active spell or anything, you just pass in the spell name to get damage. And then I make sure you have the spell. And if you do, and you have enough mana, you can cast it. But if you don't have enough mana, then it just returns 0. You like whiff your turn, basically. So I'll push that stuff up if anyone didn't get to complete the homework, so you can see a working example of all of the stuff. And then you have some basic stat improvement stuff from leveling up as well. Other than that, I did most of it kind of before in the previous lecture, so that'll be there. So today we're going to start our game loop. We have a good template for it. Right off the bat, I think, I need something to fight in my game. So I'm going to make one more base class before I actually start my game loop. Is I'm going to say we have mobs, bad guys. And I say mob.js. Same pattern as before. I can say, Miles, relax. So module export is equal to mob. Relax, Miles. So I don't know if mobs really need I guess they do need a name. We're going to spawn these guys randomly. So, this guy will take damage as well. and they're going to have health. This is stuff we've largely just done already, right? And then we'll say a goblin will be one of them. This goblin. And this guy will say cons the mob. I'm going to start going faster in my lectures if you guys haven't noticed, because this is just, we're not learning anything new right now. We're just doing what we did before. So if you're confused about this, you have the previous lecture to understand what we're doing. But this is literally the same stuff as we previously did. So wire mob for mob, and this extends mob name damage, whoops, comma, damage health, and we do super name damage health. Actually, I don't even think we need to do that. I think we can just say const goblin is equal to new mob. That's another instance of one of those. 29. So now we have a goblin, very similar to how we made spells and weapons. We have a base class, like the spell, the constructor. And we have an instance of it here that we're creating, and then we're exporting it. So we could make a bunch of mobs, and we will as well when we make our game. But now that we have a mob, something we can fight, if I go here and I say, okay, I'm going to get rid of all of this, and I'm going to play a shaman, actually. I'm going to pick shaman. Get rid of all this crap. Let's console.log my shaman. And then there's a const goblin. Sorry. So const bad guy is equal to goblin. Goblin for console.log my bad guy. Make sure that those load out. Yep. So it deals 10 damage. And it's 29 health. So how do I fight this guy for one? But how do I also make it an interactive experience? It's a good question. I could obviously just be like, function fight. We did this before in our previous thing. And say, const my damage is equal to shaman.get damage. And then, bad guy dot health is equal to bad guy dot health. Oops. Minus my damage. First off, I'm going to equip my Thunder Fury and console.log bad guy. Something like that. But I don't think that's going to be anything. I don't think that's a good thing. Oops, I got to call fight. Now he's got 16 health, and then I could run it in a loop and blah blah blah. But that's not really a game, It's just kind of like writing a test for the code. So I think we should scrap that. That's an example of what we could do given what we learned originally. Is just get the damage minus the health and maybe run that in a loop or something, right? But so instead, I'm going to say function game loop. Game loop will start and run our game. Initializing everything it needs to spawn an instance of our game. So I'm even going to get rid of my shaman. And I'm going to say const warlock, because I might pick warlock up here. Let's see, mage is equal to require characters mage. So it's just going to be a text-based game. We're not going to have a proper user interface, right? And I know some of you guys already kind of played around with how to make a user interface a little bit while you were bored in between the 3 days of the last lecture. There's a couple ways to do it properly. I think it's a good time to learn about Node Package Manager. So we're writing Node.js right now, but these requires are like requiring files locally, right? Like ./mob/goblin all that kind of stuff, characters, shaman. You could also use require to take code from the internet, like packages, like codes that other people use. So if I go to Google Chrome, and I drag over, there we go, this guy, and I say npm. This is a Node package manager. It comes with Node.js. You guys have it installed. So what we actually want to do is, I know there's a package I want to use. It's called prompt promise. It's going to help us get user prompts. It's going to do a lot of stuff for us that, we want to use. And this website, npmjs.org, will kind of describe, you'll get very used to doing this, going and finding a package. Tells you how to install it, how to run examples, and how to use it. So right off the bat, I can see this npm I save prompt promise. So we can run that locally. First off, what we need to do is go in here and say, okay, we want to prompt the user to make decisions. So we need to use a prompting library. Just like you ran git init, we can run npm init here. And you can see it's going to run me through some stuff. This utility will walk you up setting a package, a JSON file, blah, 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 package, that name. You can hit enter through all of it. It doesn't really matter. It's irrelevant. It creates this package.json file. Now we basically have an actual JavaScript repository. The same way you run git in it, and it sort of created this like git repository. We have a JavaScript repository. You need one of these in order to install packages. The list of all of your packages will basically be in this file. Every JavaScript repository you ever see, any JavaScript code base will have a package.json. So now if I can run npm install -- save that prompt promise library, it's going to go get it from the internet. And you can see it's added it to that file here. The dependencies of my app, my game, which is my name up here, game, is prompt promise. And, on average, you'll have, 50 to 100 of these mainly in a package. Because why are you going to write code to reinvent the wheel all the time, right? Maybe you even publish your own packages. Like, say you make 10 different games, but you have all this logic of creating characters and mobs and blah, blah, blah. You want to share between your games. Well, do you want to copy and paste that to 10 different folders? Or do you want to just publish your own package, which is, a one-click thing online, and then just do npm install -- save my game package. And then now you have access to all your stuff just using require in the code. So that's all you're doing. All npm is doing is getting someone else's code that they wrote. And why would we reinvent the wheel? We wouldn't. So in my game loop, I want to use it. So right off the bat, I can say const prompt is equal to require bracket. You can see it's auto-filling for me there, prompt promise. So we're using it the same way. It doesn't have any difference between that. If you hover over, you can see what it is. It exports a function. Function prompt takes a message, right? I right-click it and go to definition. You can see what it does. Module to exports is equal to prompt. And prompt is a function. So this library just quite literally returns me a function that does this. The coding is hideous, or the code is hideous and ugly, which is why people usually export them in packages. So you don't have to see this code in your library everywhere. You'll never really need to do it. But you can just see that it's just someone else's code. We haven't done anything magical here. We haven't, all we're doing is saying npm install someone else's code, and I want to use the library. So what do we want to use it for? Well, I'm going to start you guys off. It's not going to be a very long lecture today. I'll say that much, because I want you guys to start, finish figuring stuff out on your own and going down that rabbit hole. But I'll give you guys a little head start on how to use the library, because you're going to need to do something that you've never done before. And other than that, it'll just be more game logic and loops. So in my game loop, at the start, I want to get the class choice from the user. They can pick shaman, warlock, or mage. So I've got this prompt function. Yep, and it takes a message. So I'll say select your class. Shaman, warlock, or mage. So let's run game loop and just see what happens here. Cool. In the terminal down here, I get select your class, shaman, warlock, or mage. So I can say, I'll type in shaman, hit enter. Nothing happens. Now, why does nothing happen? Is the weird thing here, right? I'm going to hit enter, I type shaman, nothing happens. This is because we're using what's known as a promise. I recommend everyone after this to go read about promises in JavaScript. They are a promise to do something. They don't do it now, and you have to handle the result asynchronously. For instance, when I run this prompt, right? I run nodegame.js. My response is not instant, like the rest of the code that we've run. The other things that we've run are completely top to bottom, and then the script's done running. We did it. But this needs to wait for my user input. Who knows if I type that in 1 second or an hour from now? Promises are used all of the time. They are used for fetching something over the internet. Say I want to get my Ethereum balance from MetaMask. Well, it doesn't happen instantaneously. It needs to wait. And my code needs to know how long to wait. And we're using the same thing here. So we actually need to say that this is there's a keyword here, an async function. Game loop is an async function. And now you can see if I hover over it, it returns me a promise. That's what that syntax means. It means it returns me a promise void. If I get rid of async, I have for game loop, it just returns void, which means nothing. The function doesn't return anything. But with async, it returns me a promise. And any async function can now deal with and use promises. And how do we wait? We have to await them. So async functions can await promises. And I need to save it in a result. So I'll say class choice is equal to await prompt, not console.log class choice. All right, so I'll type shaman. Okay, cool. So at console.log shaman, I'll highlight it for you guys. Shaman. My class choice is shaman. You'll notice something else, maybe, that my script isn't finishing running after this. It's just hanging out at the bottom. Like it's not done. You see, it's just like on another line here now. Because this function itself returns a promise. So, like normally you'd have to loop or something to like pause. But like now, because we're using prompts and promises, the game will just run until we exit from this function, which is cool. If I want to exit it, I can do, throw. I think that might exit it. Going to be a shaman. Yes, it did. I got in there. So we can get user input using this. We can just say, here's the text we want to give to someone, and here is the return of the function by awaiting it. Whenever we're done, basically this prompt function is saying, as soon as the guy hits enter, return from the await. Like that's when this asynchronous code is done. So I type shaman, hit enter, and then we're good. So now that I have my class choice, I can do something like if class choice is equal to config.classnames.mage class name. See, it's very handy that I have this config class name thing. I don't even need to remember what the string was. Remember that I made that config class names in here. So Mage, Shaman, Warlock. I'm going to lowercase these actually. So my class choice is class choice. If class choice is mage, then I'm going to say, let's go up here. Let's say let character. I'm going to store my character in this variable. Once I pick a class, I will create that class and put it in the character variable. So if I pick basically this line here, the class choice says if I picked a mage, then character is equal to a new mage. Horsey. Else if the class choice is equal to config.classnames.shaman, my character is a new shaman. Horsey. Else if class choice is equal to config.classnames.warlock. Whoops, this is character is equal to a new warlock. Horsey. And then let's console.log my character. Oh, and then let's do this. Let's do else, we'll throw an error. You typed a class that doesn't exist. Cool, so we're on node game.js, select your class, shaman, warlock, or mage. I'm going to type shaman. Hey, I created a shaman. Logged out my character. So now we actually have the concept of like, dealing with user input. We can pretty much do anything. I'm not going to push this next section up to GitHub, but I'll write it in front of you guys to see, how it works. Spawn a random mob. Then let's prompt to fight it. So I'm going to go to my mobs folder. I have a goblin. I think I'm going to make a new one too. I'm going to take this and I'm going to be able to fight a dragon. Yes. And this guy deals way more damage. That's way more health and will probably roll me. And then I'll also create a file called mobs.js. And const mobs is equal to module.export mobs. I'm going to store all my mobs in here. So I'm going to say const goblin is equal to require / goblin. Const dragon is equal to require / dragon. Mobs is goblin and dragon, an array. All my mobs are in there, and then I export it. So now my game can, access this array of mobs. Let's go up here and get rid of the goblin import and say mobs equal to require / mobs / mobs. For now, I'll say spawn. Let's just take the first mob in the array. Then if we beat it, we can fight the second one. And I'll leave that other one up to you. So let's say let mob is equal to mobs 0. Good. This should be the goblin. Mobs 1 should be the dragon. Go back and make sure. Yeah, it is. Goblin, dragon. So how do I fight it? We got to kind of define some commands, right? Like some actual things. Like, do I want to attack? So first off, we can say console.log a wild mob.name appears. Let's see if that works. So let's run the game. I'm going to be a shaman. Cool, my class choice is shaman, and a wild goblin appears. So that's cool. We can log stuff using console.log for our game, and we can prompt to get users. So Or to get user choice. That's pretty cool. Let's see. So it's console.log mob mob.name plus has mob.health. Run that again. Pick shaman. Goblin has 29 health. So now we need a way to basically fight it in a loop, right? It hits me, I hit it. It hits me, I hit it. Is it something dead yet? Is it not dead yet? Get some user input in here. I think like a do while loop would be good, which is something we haven't really learned about. Unsure if that's the best way to do it. Otherwise, we have to chain if statements all the time. But a do while loop is basically you say like, while character.health is greater than 0 and mob.health greater than 0. So while both of these are true, we can run our loop. So while both my character and the mob I'm fighting both have health, we fight. When one of them stops having health, i.e. it's below 0 or equal to 0, this block will stop running. So this is different than a for loop. This is the only other kind of loop. There's only 2 loops really in coding. There's for loops which run, you give it a certain amount of times to run. And then there's do while loops, which is, do this block while this is true. So if you write this while true, this will run infinity forever because true is always true. You'll just run this block and then run it again, then run it again, then run it again, then run it again. And if you write while false, it'll never run it because false is always false. So we want this condition while character health is greater than 0 and the mob's health is greater than 0. We want to fight. So I can say, let's say, const move is equal to prompt select a move, fight, spell, or let's just say fight or spell. And I'm not going to make it very flashy, but I'll say console.log character.spells. Let's say your character's spells. See what that looks like. Pick a shaman. Oops. I cannot add that. Your character's spells. Character.spells. Run that, shaman. There. Now it shows my spells. I have light heal. I didn't do the healing mechanic, so for now it'll deal damage, which is fine. So it's saying select a move, fight, or spell, so I can type in again, fight or light heal. But of course, you see that this is the do while loop in action. Because I'm not reducing the health, the character.health or the mob.health, no matter what I hit, it'll just do the prompt again. Fight, spell, blah, blah, blah. Doesn't matter. So that's the do while loop in action. So what I actually need to do now is say, I've got the move. So we can console.log, you selected. Let's move. Let's run that again. I'm going to pick a shaman. Actually, I'm going to pick a mage. There you go. I'm going to pick fireball. So you can say you selected fireball. So we have the input from the user again. We've said, you picked fireball. just going to keep running. So now I need to say const damage is equal to my character dot get damage. And now we're kind of seeing the benefit, if anyone's keeping up with this without having to rewatch it later, of having that base character class, because we've selected either a mage, a shaman, or warlock, but we're treating all of them the same way. We're going to treat them all identical. We have a base character class, and they all have a get damage method, which we know from over here. They all have a summon pet method. They all have a level up. We can treat them all the same way. It doesn't matter which one the user picked, and that's why we did that early on. So we just create a let character, and then we assign that variable depending on what happens in the class choice. And then now we can just call get damage. So I'm going to say get damage, and I'm going to pass in my move. Let's console.log the damage. You attack for plus damage. Let's see, I'm going to pick a mage, and I'm going to use fireball. Hey, I attack for 12. Cool. More user input. That's pretty sweet. We got the damage just from the text. So, const mob damage is equal to the mobs.damage. Console.log. Mob.name hits you for mob.damage. I keep running it. I keep running it every time to make sure all my stuff is working. I cast fireball. I attack for 12. Goblin hits me for 10. Create a space there. That's cool. Okay, so now I can say mob.health is equal to mob.health minus the damage, and character.health is equal to character.health minus the mob damage. Console.log fight over. So let's run a little iteration of our game. I'll pick a mage. I'll cast fireball. You attack for 12. Goblin hits you for 10. Okay, I'm going to keep casting fireball. Fireball. Oh, and I attack for 12. Goblin hits you for 12. Fight over. So our do while loop broke. One of us died. I don't log out which one yet because I'm not logging out the health at the end of each fight. But one of us died. So let's try that again. Let's say console.log. Your health is plus character.health. Console.log. Mob.name plus health is plus mob.health. Try it again. I'm going to spam fireball until I beat the shit out of this guy. You can see here. Your health is 30. Goblin's health is undefined. Okay, I fucked up. Mob, I spelled it wrong. Mob.health. There we go. Okay, mage. Cast fireball. Your health is 40. Goblin's health is 17. Cast fireball again. Your health is 30. Goblin's health is 5. Cast fireball again. Hey, Goblin's health is minus 7. My health is 20. The fight over. So it's pretty cool. We can get user input and we can make decisions in our game based off of that, which is pretty fun. You know, if I play my game and I cast game.js and I pick a mage and I have a spell named Fireball there and it logs it out, I'm going to cast Thunder, and you can see I attack for 0 because I don't have a spell called Thunder. And my logic and my character here, if I get damage, I search for the spell, and if I don't have the spell, then I return 0. So it's a bit of fun logic. So you can see here I can actually like play my game generically, and like I can run my game again, and I can, you know, play a shaman, and I can cast light heal, and then I'll attack light heal. You attack for 13, Goblin hits you for 10, light heal. So like I'm playing the game the same way without even caring what class I am after this, because they all function the same thing. I'm logging that stuff out dynamically to the user, just saying, yeah, we all get spells the same way, all that stuff, you know. I'm not going to input it. It's going to be your guys' job, but you should be able to select an option to summon a pet so that the next time you attack, you can use your pet. You should be able to maybe use potions or items. And, you know, if this had a graphical interface, this would literally be a game. Like, this is how it works. This would quite literally be a game. You know, in a GUI-based game, you'd click a button and it would just react the same way that the user input does. A wait prompt would be waiting for a button to be clicked instead. This would be pseudocode. It would be like, you know, click button. And depending on which button you clicked, we'd know which move you cast. We do the same thing. We get the damage. We get the mobs damage when they hit you. Yada, yada, yada. Minus an attack. Kind of the same thing. So I'm going to go over what we did today, and then the homework's going to be, you know, implementing the rest of the game into this loop, getting a random mob to fight, creating a whole bunch of mobs, which, you know, will be fun, get you practice writing classes and declaring the variables and exporting them, keeping your mob array and updating it to pick from, using npm to get the prompt package, changing the function to an async function, awaiting the prompt response, adding a new line to every prompt, because, like, you know, look at mine just wants it on the same line. I think that might be this. Is that a new line in here? Yes, it is. So you can see I did that. So this character means new line, /n/n. So I can add those to the end of my prompts. And then now it's a little bit cleaner. So I'll pick a shaman. Maybe here. Yeah, it looks a little bit cleaner. Yeah, I could log out my character's mana as well, which will be part of the homework, to log out all your stats. And then after you kill something, to level up if you won, if you're not dead. With this prompting and these loops, we can really do a lot to make a full game. So to reiterate, you know, npm, if you run npm init, just like you ran git init, you can initialize your folder as a JavaScript code repository. And then you can do npm install to get packages. And we grabbed prompt promise, which is some code some dude wrote that looks ugly under the hood, but lets us just one line, get a user prompt and store it in a variable. Whatever the guy types, you store it in a variable, which slaps. And then we required it, just like we required local code with /. We just required it with the name of the package. It exported a function, which we can hover over and see it says function prompt. If we want, we can right click, go to definition, and it'll show us the code. And you can see where the code is here. It's in the node modules folder now. It's added us a node modules. We have character, config, mobs, and node modules next to spells and everything. That's where all your dependencies live. So you can see I have prompt promise in here now. That will that'll show you this kind of like code the dude wrote under the hood. And we'll get into publishing our own simple package later, so this is less magical. Maybe we'll publish the game as a package and consume it elsewhere. But once you have that prompt function, you can make any regular function async and then await stuff. So overall, it's a lot of what we've already know how to do, the actual like logic. You know, you've learned while loops. While this condition holds true, do this loop over and over and over. And this loop is just dealing damage, picking spells, or attacking, and till some guy died. And you can add anything you want in there. You can add potions and all that kind of crap. Maybe you have more logic, and after every fight, you know, a shop appears, and you can add a shop to your thing, and you get to buy something if you have gold, blah, 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 like that. It's really endless here. So I'm going to add a bunch of that stuff for homework. And then, you know, it'll be fun, obviously, is every time you level up, maybe you can pick a spell. So you can call level up, and then you can do a prompt to get pick them that's 3 spells they don't have, and then they get to pick one of those from the prompt, and then they add that to their this dot spells. You push it in, and then the next time they fight, when they select a move, you can use that spell until you die. And then, once we have that loop going, we can actually clone each other's GitHub repos and play each other's games, which will be fun. We get a little competition or something, and find bugs in each other's games or something, which will be a blast, I think. Yeah, that's pretty much it for today. Any questions?
So I see it on the console log you're using the plus instead of a comma. Is that, can you do that in other places, or is it just on console log?
Well, you can add 2 strings together. So normally what I would do this. I would say, that's how I would actually do it. This is a template literal. So you put backticks here instead of the quotes, and then you can enclose variables in a $ and a bracket without having to add or comma. And that way you don't have to combine anything. But I wasn't sure if anyone knew how to do that yet. So, you can use a comma here, or you can add 2 strings.
Yeah, I was gonna say that's what the AI showed me, was using that.
I always do that. I would never do it like this, but I'm trying not to overwhelm people with new syntax at the same time as I'm teaching stuff. But so how this works is, you can do a comma here. You can. Or you can do a plus. If you do a plus, you're passing in 1 argument to console.log, right? Because you're adding these 2 together, these 2 strings. Like you attack 4 plus the damage. If you use a comma, you're passing in 2 arguments.
But if those 2 happen to be numbers, it actually does the math on them, right?
Yes. It does not. If you would add a string to a number, it'll treat the number as a string. So the damage is a number, right? So I'm adding it. So it's saying you attack 4, 13. It's adding 13 to the string.
Yeah.
It's not
just if the 2 things that you were passing in happen to be numbers, they would add them in together rather than displaying them separately, right?
Yes.
Clarifying for myself.
Yes. So the way the console log works is if you hover over it and you even right click and go to definition, is this ... syntax for a function argument. It means as many parameters as you want. So you can pass in infinite things with comma to console.log and it'll work. You can be like console.log 1, 2, 3 false, hello, 9 string, 4 true, etc. Console log doesn't care how many things you pass into it. It's got a magic syntax, a variadic operator it's called. But I wouldn't worry too much about that right now. I would just either use a comma, a plus, or the template literal that I just showed. And then you attack 4 damage. I think this is the cleanest way to do it because you don't have to you can kind of see what you're going to be printing a little bit easier in my mind. Most people would use these template literals, just using the value of the variable in the string. I kept it to adding 2 strings together so that you guys didn't get overwhelmed, but feel free to use whichever one you think is the cleanest. Anyone else? Any questions? Nothing? Makes sense to everyone? Everyone gets it? Sounds good. You're bunch of
Yeah. The only thing I was going to say is later when you mentioned using GUI to actually interact with it.
Sorry, what's that? What's the question?
It's not really a question. It's just more of you talking about using GUI to interact with it later when we learn HTML, I guess.
Well, it's not just HTML is a web app, right? You could also plug this logic into Phaser or like the things I made battle cranes with, like those shitty JavaScript libraries, and just make for this, right? Move your character around built in with those libraries. There's a lot of options. Or you could make it HTML and just make a more text-based website.
Yeah, that's what I meant. It's just having a GUI so that you can actually tap what choice you want and stuff.
Yeah, exactly. Yeah, you can make it clickable. For now, we're going to keep going down this rabbit hole because you have to hook up the HTML elements to buttons and then plug them into the code. And I often find when people learn at the beginning, it's a little bit tricky for them to like manage that relationship between it. It's kind of easier here just to like do it in the terminal while you get the hands of this. But probably within like 10 days or so, we'll be doing HTML and plugging in JavaScript code to it. We're not going to make another game, but we will be doing like on-click events when you click a button on a website kind of thing.
Okay, yeah, that's what I was wondering.
Can you go back to when you, at the beginning, you said that instead of doing the strings, you made it more robust by sort of choosing from an array instead of typing in, yep.
Not an array, an object.
Yeah. Okay. An object, not a class.
Yep, an object. Yeah, I don't need a class. This is a perfect example of a class. I'm going to add tons of config. Like I have a total config object that has a class names property, which is another object. And I can add lots of different config stuff to this. I could even have like game name here, and it's like Horseman 5000 game. Now I have config.game_name. So when I go to my game.js, the first thing I could do in my game loop is like console.log. Welcome to config.game_name. I run it. It says, welcome to Horseman 5000 game. So that big config object for me in my config folder just holds a bunch of configuration shit, which is a really common pattern in coding. Because like you might want to use the name of the game when you get game over as well. Like you just lost the Horseman 5000 game. But if you don't put it in one place, you have to go change it everywhere, right? You got to go change it in like a bunch of different spots. So it's easier to put it in one spot here. And then if I ever change the name of my game, I just go change the value of this. But I'm actually using config.game_name everywhere. So it doesn't care. Does that make sense?
Mm-hmm. Are you going to make another file under config, or are you just going to use that one classnames.js?
You know, I would probably actually call this if this did grow and I did add more than class names to it, I'd probably just rename it this to config.js and do that.
Yeah. Yeah. Okay. Got it.
Or I could create multiple objects. I could just call this like class config or something. Something that's easier, class config, and then I could get rid of this nested properly. And then now I could just say class config.mage class name. But I would probably have one big config object, to be honest, and have all of it on there. It's just a little bit easier.
Right, because then you're just typing the same thing every time, config dot whatever, instead of having to remember which name your interior class is. Okay.
Yep, big time. Yep, it's reduces cognitive load for sure. Anyone else? I'll stop sharing my screen then.